Okay, for this lesson we're going to talk about the graphs of inverse trig functions. So we need to revisit the definition for inverse. For a relation to have an inverse, it must be a function and one-to-one. Okay, so also an inverse is a reflection over the line y equals x. To find an inverse graphically, we're going to switch x and y coordinates. Now, so for it to be a function, it has to pass the vertical line test. No repeating x coordinates. One-to-one has to pass the horizontal line test. So if we graph y equals sine x from negative pi to pi, okay, so if we do this graph, sine curve, remember, we're starting at 0. We're going 30.866 up to 1 at 90, back down 8.866.5, back to pi, or 180. And then the opposite direction would be negative 0.5, negative 0.866, negative 1 at negative 90. Then we'd be at negative 0.866, negative 0.5, back to negative 180. So it looks like this. Okay, so the question is y equals sine x a function? Yes, it passes the vertical line test. Is y equals sine x one-to-one? No. Here's the problem. It is not one-to-one. In order for it to have an inverse, it must be one-to-one. So if we restrict the domain of the sine function from negative pi over 2 to pi over 2, the subset of the sine function is one-to-one and has an inverse. So if I take and I look at only this to here, then you can see that it's a function and it is one-to-one. So, sine function with restricted domain, y equals sine x, the domain is negative 1 less than or equal to x less than or equal to 1. The range is negative pi over 2 less than or equal to y less than or equal to pi over 2. Key here is that it's a restricted domain. Okay, otherwise we'd say the domain's all reals for sine, but because we're looking at the inverse, with the restricted domain and the range, oh, I have those backwards. Hold on. All right. So the domain is negative pi over 2 to pi over 2, and the range is negative 1 to 1. Okay, sorry about that. All right, now the inverse sine. So what I'm going to do for that is take some points. So I'm going to take the graph of y equals sine x. So at negative 90, we should be at negative 1. You can see that from the graph. I'm going to just plop in there negative 45. That's at negative 0.77. You should be able to see that. 0, 0. Then I'm going to do 30. We are at 0.5, 60, 0.866, and 90 back to 1. Now if I want the inverse, which is y equals sine negative 1 of x, then I'm going to literally switch the x and y coordinates. So -1, -90, -0.77, -45, 0, 0.5, 30, 0.866, 60, and 190. So you can see the restricted domain on the y equals sine x is going from -90 to 90, range is -1 to 1, and that gets reversed for the arc sine, or the inverse. So now the domain is going -1 to 1, and the range, if you look up at the y coordinates of the inverse, is going from -pi/2 to pi/2. Now, if we're going to graph this, then look at your x coordinates. They go from -1 to 1, and now your y coordinates go from -90 to 90. So over here now, when I'm going to graph this, my x coordinates need to go from -1 to 1, and now I need to go up here is pi/2, and on the y-axis down here is -pi/2. This is still the x and y axis. So now when I go to graph this, I'm going to go -1, -90. I'm going to go -0.77, -45, so maybe like right around there. 0, 0. 0.5, 30. 0.866, 60. And 190. So now the graph of the inverse looks like that. On the next page, we're going to be talking about cosine. So if we look at cosine from 0 to 2 pi, okay, so here we go. We start up 0, 1. At 90, we are at 0. At pi, we are at -1. At 270, back to 0, and 360 back up. So there's my cosine curve. So is y equals cosine a function? Yes. Is it 1 to 1? No, it does not pass the horizontal line test. It has repeating y coordinates. So if we restrict the domain of cosine to 0 to pi, the subset of the cosine function is 1 to 1. We already did this back in the last chapter, but here we are with the graph of it. So if I take and only look from 0 to pi, at just that little green line there, it's going to be a function and 1 to 1. So now the domain for that was 0, less than or equal to x, less than or equal to pi, and the range was -1 to 1. So to graph the inverse, I'm going to start with y equals cos x, and then flip the points. It's easier, if you're asked to graph it, it's easier just to start with y equals cos and then flip them. If you're doing multiple choice on like a Regents exam, you can put your calculator in radian mode and graph y1 equals second cosine x, and same with second cosine sine or whatever, and you should be able to see a graph. But in terms of actually accurately graphing, it's better to do it this way. So for y equals cos x, I'm at 0, 1, and then I'm going to go 30. At 30, I'm at 0.866. At 60, I'm at 0.5. At 90, I'm back to 0. 120, I am at -0.5. And 150, I'm at -0.866. And 180, we are at -1. So the inverse would just be those points flipped. Okay, so now let's go and graph those, and you can look at the domain. The x-coordinates for your inverse are going again from -1 to 1, and your range now is going from 0 to 180, or pi. So the graph of this, I'm going to put that x-axis a little bit lower. So here's -1 to 1. Here's 3 spaces, that's pi over 2, or 90. 3 more spaces is pi, because we're right here at 0. So I'm going to first graph 1, 0. So here's 1, 0. And then 0.86630, 0.5, 60, and 0, 90. -0.5, 120, -0.866, 150, and -1, 180. So that one looks like that. Okay? If you took the graph of the cosine curve and you reflect it over the line y equals x, it should look like the arc cosine curve, or the inverse. All right, and the last one is the tangent. Okay, so for the tan graph, let's start off in the middle here. So remember, we have at pi over 2, we have an asymptote, and at -pi over 2, we have an asymptote. And the tan of 0 is 0. The tan of 45 is 1. The tan of -45 is -1. So our graph looks like that. And if we kept going and graphed over here to pi, okay, then this one would be down here, and it would look like that. And this one over here, if we went back to -pi, would be starting at 0 here, halfway would be up to 1, and it would look like that. Now that is not 1 to 1. Is it a function? Yes, but again, it is not 1 to 1. So if we take and we restrict the domain so that we are kind of including the -pi over 2, but not really, you're not going to include them per se. But if you just look at it from -pi over 2 to pi over 2, then you will get it to have an inverse. It will be 1 to 1. So the domain, if you look at our tan graph, is going to be -pi over 2 is less than x is less than pi over 2, and the range is all reals. Now if I want to get the domain and range for the other one, I'm going to again go to y equals tan x and y equals the inverse. So getting some points, I would have -90 was undefined, -45 is -1, 0, 0, 45, 1, and 90 undefined. So it's kind of going to be hard to do undefined -pi over 2. I'll have to show you what that looks like. -1, -45, 0, 0, 45, 1, and 90 undefined. So to graph that, well, first we can look at the domain. The domain is all your x's. Your x's are going from, oops, wait a minute, made a mistake here. This needs to be undefined, 90. Okay, so your domain is actually going to be all reals, and it might be easier once we graph it to get the domain and range. So let's just wait for that. So here's your x-axis, y-axis. Okay, so here's going to be, I'm going to put -1 here and +1 there. And I'm going to put pi over 2 up here and -pi over 2 down there. And it's undefined at pi over 2, so the asymptote goes like this. Okay, and then -1 was 45, so that's halfway between 0. Oh, sorry, -1 was -45, so that needs to go halfway between down here. And then 0 was 0. And then at 1, we are at +45, so halfway. So this then would keep going. You could have other values for x, like you could put, in this instance, you could put -2. This one's a little bit trickier. You could put -2, and so it's just going to go along there and along there. So that's not the best looking graph. Kind of maybe goes along like that. But there's your inverse of tan. So we say the domain is all reals. And the range would be -pi over 2 is less than y is less than pi over 2. So you should see that the range of the inverse is the domain of y equals tan, and vice versa. Okay, next page. So some trig examples, what we've seen in the last chapter, are these. So an inverse trig example may look like this. Y equals arc sine 1/2, or y equals sine -1 of 1/2. This means I'm looking for an angle Okay, I'm looking for an angle in the restricted domain for sine whose sine is 1/2. Maybe I should state that better as where instead of whose. I should say where the sine of the angle that we're looking for is equal to 1/2. And the restricted domain for sine is -pi over 2 to +pi over 2, or -90 to 90. You can simply solve these problems using your calculator. Second sine 1/2, enter. So y equals sine 1/2, arc sine 1/2 is going to be basically also kind of saying like theta equals arc sine 1/2, and theta turns out to be 30 degrees, or in radians, pi over 6. For number 2, second cosine of 1/2, so I'm going to replace y with theta. Theta would turn out to be 60 degrees. This one's restricted domain is 0 to pi, including pi and including 0. So this one's 60, or pi over 3 radians. For number 3, second sine, so to the home screen. Second sine 0 is 0. So this again, theta is equal to 0 degrees or 0 radians. Number 4, theta is equal to arctan radical 3 over 3. Theta would equal 30 degrees or pi over 6 radians. Now for tan, this restricted domain we did up above or on the previous page. So this restricted domain is negative pi over 2 is less than x is less than pi over 2. I should probably go up and write that a little bit nicely for the more nicely for the cosine, which is 0 less than or equal to x less than or equal to pi. All right, so our cosine, I'm just going to literally do second cos negative radical 3 divided by 2. And it's going to say 150. So theta is 150. And then 150 times pi over 180 turns out to be 5 pi over 6. For number 6, again, I'm going to do second tan of negative radical 3. And so theta is going to be negative 60. That's between negative 90 and 90. So it's that or negative pi over 3 radians. Number 7, I think we have a negative in there, so it's going to be second sine negative. So theta is going to turn out to be negative 30 degrees or negative pi over 6 radians. And second cosine 0, theta turns out to be 90 degrees or pi over 2 radians. Now a little bit harder, we have sine arc cosine 1/2. So arc cosine of 1/2 is really looking for what is the angle where the cosine's 1/2 from 0 to 180. Well, that should be 60 degrees. So arc cosine of 1/2 is really 60 degrees. So the sine of 60 then turns out to be radical 3 over 2. And then this is the angle whose tan is negative radical 3. Well, that was negative 60 from up above. So the cosine of negative 60, I'm going to QRS that. That's in quadrant 4. The reference angle is 60. The sine is positive. So cos of negative 60 is equal to positive cos 60, which is positive 1/2. And so that's how you would go about doing those. Those should be review. That's the end here. So have a good night.